In this training, we will explore the concept of policy as code, and the benefits provided by policy as code to implement the infrastructure. We know that following policy is extremely vital. There are different tools that can help us identify the right policy that needs to be integrated into our configuration management and infrastructure setup. So, let's explore the critical features of policy as code. Policy as code is the idea of writing code using a high-level language and adopting the right policies, which includes the use of code to manage and automate those policies. Once you have specified those policies while executing infrastructure as code, you'll find that they are applied to the system. Policy as code can be implemented by writing policies as code in the text files. Also, it is important to keep in mind while writing policy as code, we need to adopt best practices, which include version control, automated testing, and automated deployment. Now let's discuss some of the prominent benefits of adopting policy as code. The first benefit is sandboxing, where policies provide the baseline for other automated systems. And we know, as the automated system grows, there will be challenges to protect those automated systems from various malicious actions. Manual verification is too slow for such. So, we must write policies that need to be represented as code to ensure that we can keep up with other automated systems as well. The second important benefit is codification. When we represent policy logic as code, the information and logic about a policy is directly represented in code and can be augmented with comments rather than relying on the traditional approach to learn about the policies. The next benefit is proper version control. Policies are always encouraged to be stored as a simple text file, which is managed by the version control system. This helps us gain all the benefits of the modern version control system, such as reviewing history, finding the difference between two different policies, pull requests, and all the facilities which are provided by version control. The fourth benefit is testing. Since the policies are codified, syntax and behavior can be validated using the right validation tool. This also encourages applying automated testing of your policy as code. When paired with a version-controlled system, it allows a pull request workflow so that we can verify that a policy keeps the system behavior as expected before merging. Finally, we have automated. With all policies as code written in a simple text file, we can use the right automation tools to automate it. Now let's try to understand policy enforcement levels. The policy enforcement level is tightly coupled with the tool selected to adopt policy as code. Let's explore the three enforcement level. The first is advisory. The policy adopted is allowed to fail, however, we can put a warning message that lets the user acknowledge the consequences. Next, we have soft mandatory. When we adopt soft mandatory enforcement level, the policy must pass unless an override is specified. The third is hard mandatory. When you apply hard mandatory enforcement level, the policy must pass all the checks with no exceptions. The only way to override a hard mandatory policy is to explicitly remove it from the policy. Now, let's explore the prominent tools we can use to work with policy as code. The first tool that we will explore is Console. Console comes with a built ACL system to provide advanced policy enforcement. Next, we have Nomad. It comes in an enterprise version, and it is used for applying advanced policy enforcement. The third tool is Terraform, which uses tools like Sentinel to enforce policy on Terraform configuration, its state, and the final plan. And finally, we have Vault, which has a built-in policy system to provide role governing policies and endpoint governing policies that enable complex flexible policies across identities and selected endpoints. To conclude this video, let's explore the elements of policies as code. First, we have rules, which form the basis of a policy. It is represented as a behavior that can pass or fail. We can say that rules are first-class language constructs used in various policies as code tools. We can have a policy that can be broken down into rules to ensure that it is readable, testable, and highly performant. The second element is tracer. Tracers are useful in ensuring that we can understand the current state of a policy in execution. The third element is testing, which is a mandatory step to fully realize policy as code. We can always apply a similar testing approach, which applies to normal codes. Finally, we have imports. Imports enable policies to access all the reusable libraries and external data and functions if available.